Imagine your app is becoming popular. So popular that a single server just can't keep up with the traffic. You could try beefing up that server with more RAM, faster CPUs, and bigger disks. But that's like adding more arms to a single chef during a restaurant rush hour. It's still one chef. Instead, what if you had a whole team of chefs sharing the load? That's the concept behind load balancing, and Azure offers a powerful solution. Azure Load Balancer. Azure Load Balancer is a layer 4 load balancer that helps you distribute incoming traffic evenly across multiple virtual machines or VM scale sets in your Azure environment. Instead of one server drowning in requests, multiple servers, your backend pool, take turns handling incoming connections, improving both availability and performance. At its core, Azure Load Balancer uses load balancing rules and health probes. Load balancing rules decide how to map incoming traffic to backend VMs. You specify the front end, like IP plus port, and the backend pool, like VMs plus port. Health probes constantly check the status of your backend VMs. If one goes unhealthy, it's pulled out of the rotation, so it doesn't receive traffic. Azure gives you two flavors of load balancer, and you'll choose based on where the traffic originates from. And they are public load balancer and internal load balancer. You use public load balancer when you want to balance internet facing traffic. Think of a website or a public API. Users hit a public IP, and Azure routes those requests to one of your backend VMs. It maps the public IP and port to private IP and port of backend pool members. It can also handle outbound traffic so that your internal VMs can access the internet using source network address translation. For example, you've got a web app with thousands of users visiting every hour. A public load balancer helps distribute that traffic across multiple web servers in the backend. Internal or private load balancer is meant for private traffic only within your Azure virtual network or across a VPN connection. It never exposes IPS to the internet. It balances traffic across VMS for backend services like databases, application logic, or internal APIs. When you're working with internal traffic in Azure, there are several common scenarios where using an internal load balancer makes perfect sense. For example, if your front-end and back-end VMs are all inside the same virtual network, you can use the load balancer to evenly distribute traffic between them, ensuring efficient performance. If you are connecting your on-premises systems to Azure through a VPN, the load balancer can manage that cross-premises traffic within the virtual network, keeping things smooth and secure. In multi-tier applications, where the public tier needs to send requests to backend services that aren't internet-facing, an internal load balancer ensures that traffic flows properly without exposing sensitive tiers. And when you are running internal line of business apps like finance, HR, or analytics, your team can access them seamlessly through Azure without needing to invest in any extra hardware or third-party load balancing tools. Azure Load Balancer supports both inbound and outbound scenarios and scales up to millions of concurrent TCP UDP flows, making it suitable for even the most demanding workloads. It's natively integrated into Azure, which means you get high throughput and low latency without any third-party dependencies. So, what's your key takeaway? When you deploy your application in Azure, you want to ensure it's resilient, scalable, and responsive. That's where Azure Load Balancer shines. Whether you're serving traffic to the world or just internally between tiers of your app, load balancing gives you a smart way to distribute traffic, avoid overload, and maintain performance. So next time you design your Azure app, remember, you don't need one superhero server. You need a balanced team working in sync.